Welcome to solverfy.
For this question, we are going to be using this balanced equation for the combustion of glucose. And for the first part of this question, they are wanting us to find the volume of CO2 produced by 20 grams of glucose. So they tell us that our mass of glucose is equal to 20 grams. And they tell us that the temperature for the reaction is 37 degrees Celsius. I'm just going to add 273 Kelvin to this. So our temperature is going to be 310 Kelvin. They tell us that the pressure for the reaction is equal to 780 torr. I'm just going to change this into atmosphere by timesing it by 0.0013159 atmospheres per torr. So our pressure is going to be 1.03 atmospheres. And they are wanting us to find the volume of CO2 for this reaction. Alright, so for part A, to find out the volume of CO2, we need to find out the moles of glucose to start out with. So moles of glucose. And we know that the molar mass, abbreviated mm, of glucose is equal to 180.15 grams per mole. So to get our moles, we're just going to take the amount of glucose we have in our reaction, so 20 grams of glucose, and we're just going to divide that by its molar mass. So our moles of glucose is going to equal 0.111 moles. Alright, so now that we have our moles of glucose, we can now get our moles of CO2. So if we go up here to our balanced equation, we can see that we have 6 moles of CO2 for every 1 mole of our glucose. So we're going to take the moles of glucose, so 0.111 moles glucose, and we're going to times that by 6 moles of CO2 and divide that for every 1 mole of glucose. Okay, so our moles of CO2 is equal to 0.666 moles. Alright, so now we just need to find the volume of CO2. So volume is equal to moles times our R value times our temperature divided by our pressure. So our volume is equal to our moles of CO2, so 0.666 moles, times that by our R value, which is 0.0821 liters atmosphere per mole Kelvin, and I'm going to times that by our temperature, so 310 Kelvin, and we're going to divide that by our pressure, so it's 1.03 atmospheres. So our volume of CO2 is going to equal 16.5 liters. Alright, so that is how we solve the first part of this question. For the second part of this question, they are asking us to find the partial pressures of each gas when the reaction has only been 50% completed. So when our reaction is only at 50% completed, we have half of our O2 moles consumed by the reaction. So if we have 1 mole of O2 to every 1 mole of CO2 based on our balanced chemical equation, for our moles of O2, CO2, and H2O are all going to equal 0.333 moles because it's half of what it was when the reaction was completed 100%. So for the partial pressure of water, it says that we know that for the pressure for water at 37 degrees C or 310 Kelvin, our partial pressure of water is equal to 48.8 torr. So I'm just going to convert this into atmospheres by timesing it by 0.0013157.9 atmospheres per torr. So our partial pressure for water is going to be 0.0642 atmospheres. All right, and this is our partial pressure for the water vapor. And they tell us that the total pressure is equal to 1.03 atmospheres. So if we know that the partial pressure for CO2 and the partial pressure for oxygen are equal because they have the same number of moles, we can say that the total pressure minus the partial pressure of water is equal to double that of the pressure for CO2 and oxygen. So when we calculate this out, it's going to be 0.9658 atmospheres. Again, this is both for CO2 and oxygen. So to get the partial pressure for CO2 and oxygen, we're just going to divide this number by 2. 6. There we go. 0.9658 divided by 2. So this is going to equal 0.4829 atmospheres. So this is going to be the partial pressure for CO2 and the partial pressure for oxygen. And that is how we calculate the partial pressures for this reaction.